Welcome to a new session, and in this session we are going to explore how to set up a custom VPC. So we know what a VPC is. We understand that VPC is the backbone of any not just the AWS cloud platform. Any cloud platform requires this virtual network at the background, within which the security of your entire account is going to be managed. So all your instances, all your applications are going to be working within this VPC only, right? So I hope you have already gone through the documentation which I had given earlier. Now let's go ahead and set up a custom VPC. So what are the primary components that work towards setting up the custom VPC? So the first part is the VPC itself. Then we have the subnets. Then we have the route tables. Then we have the internet gateways. Then we have the network access control lists and the security groups, right? Okay, so when we are going to create a custom VPC, all these 6 components are going to be working together. Not just the custom VPC. In case of any VPC, these are the 6 components that are going to be working together to form the complete VPC, and your resources, your application, your website, all of them are going to be managed from within this entire setup only, right? Okay. The first step, let's go and have a review of all the 6 components, how many are there, and how they are being set up here. So remember, there is one default VPC which is available for every single region within the AWS platform. Okay, so if you go to the EC2 global view, let's see there, and in this you will be able to see all the list of regions that's been activated for your account, and within this you will see that there is one, by default there will be one VPC for your for the region within your account. You see here all of them. For example, this Cape Town is not opted in. So other than the not opted in, and which you already have access to, you'll see there that there is one default VPC. Okay, so within the VPC comes the subnets. So we know what are the subnets. The subnets are the AZs, right, or the availability zones. So the number of VPC, within the VPC you can control the number of subnets also. Let's say within the VPC you need only 2 subnets. You don't want all your subnets, so you want to place only 2 subnets. Yes, you can control that. All right, so you can see here that there is for example, Europe Stockholm has only one VPC at the moment. It's not just it is having one VPC, it is by the default that AWS creates for us. All right, so let's go ahead and see the VPC here. So now let's say let's take as usual the Ohio region, and within this we see that there is one VPC. There are 3 subnets. So there is there are 3 availability zones, and each availability zone has a subnet, right? There is one route table which references to the entire VPC. There is one gateway which references to the default VPC, and other than this we have the network ACL and the security group. So these are the primary options that it's always working together, and please keep this in mind. So the 6 components you always need to keep in your mind. So the VPC, subnet, route table, internet gateway, NACL, and the security group. Now let's see what is happening when we are creating a custom VPC. So let me go to your VPCs first, and I have one VPC which is currently using a IPv4 network private IP address range of 172.31.0.0/16. Okay, I'm going to create a VPC now, and um, I'm not going to use this, VPC and subnets and all the resources. I'm going to use only the VPC. All right, and I'll call this as custom VPC 1. Here we have the IPv4 header block and the IPv6 header block, but here for this demonstration, I'm going to be using only the IPv4 VPC. All right, and I'm going to be placing the VPC within the network range of 10.0.0.0/16. So which means that the network range is going to be 10.0.0.0. The net mask value is 255.255.0.0. And by right, the internet gateway for this particular network range is going to be 10.0.0.1. Alright. So I've set the IPv4 CIDR for the entire VPC. Next comes the tag. I'll put this as okay, I'll leave it as it is. I'll just leave it as name and custom VPC. I'll create VPC now. Well, yes, that was pretty simple. So the custom VPC got created. Alright, so let's see what's happening with the others. So as for the subnets, okay, we are having 3 subnets here, and you see all of the 3 subnets belong to the default VPC. Alright, so there is no subnet actually getting created automatically for the custom VPC which we create. Alright, okay. Next, let's click on the route tables. Okay, so we have one route table which has got created along with the custom VPC. Alright, let's click on this. And it is going to give the route for the entire VPC. Alright, I told you that, the route, we can create multiple route tables. It's not that, we are going to be having only one route table. We are going to be having multiple route tables, or you want to create multiple route tables, it's up to you. However, you go and see here, you have the subnet associations. So what we will be doing is, once a route is getting created, you can go and manually assign your subnet associations based on your requirement. But what will differ, or what is going to happen here is, this first one which gets created will be called as the main one, and however the other custom, not the other route tables which you are going to be creating are going to be called as not main. Okay, please remember this. Next comes the internet gateways. So the internet gateway is the entry point of the data from outside the world, and the data that's going to be traveling from within the network to the outside world. All this is going to be happening through the internet gateway only. So we see here that there is one default, there is one IGW which has been assigned to the default VPC. So we did not have any internet gateway created automatically when I created the VPC. The next option is the NACL. So we'll see one NACL which is getting created here, which is associated with the custom VPC. And last of all, the security groups here. We have one security group which has got created, which is the default one. And within this one, you'll see it is the inbound rules and the outbound rules are going to be all traffic. So we know about the security group pretty much because we have worked extensively with this security group since the beginning on the EC2 at many use cases, right? Okay. So remember, now what has happened is when we created the custom VPC, we had one VPC got created with a specific IP address range. Subnets were not created. One route table which was named as main got created. Internet gateway was not created. One network ACL was created. However, within the network ACL, there are no subnet associations here. And security group also, there is one default security group which has been created. Now let's continue and set up the remaining setup. Okay. Now let me go to the subnets. Okay. I'm going to create 3 subnets. Now I know Ohio has 3 availability zones. So let me go ahead and create 3 subnets. Okay. So select a VPC. I'm going to select the custom VPC. All right. The moment I select that, I'm getting the option here, and I'll call it as custom subnet. And this we will put it in US East 2A. So I'll call this as custom subnet 2A, or to be more precise, we will put it like East 2A. East 2A. Alright. Availability zone, I'll select it for 2A, and the IPv CIDR, that's most important. So now what has happened is, within the 10.0.0 network range, I'm creating a subnet, and for within this availability zone, and here what I'm going to use is, I'm going to use the 10.0.1.0 series with a netmask value of 255.255.255.0, which means I can have about 256 hosts within this subnet. That's the maximum. Alright. However, if you want to go ahead and change it, let's say you can put it like 10.1.0.0, so that it can be more, it can accommodate more hosts. Alright. Okay. But remember, there is only one subnet getting created. But I can create multiple subnets within the same page. Next, let me go ahead and create, and I'll call this custom subnet 2-east-2b. The previous one was 2A. I'll call this as 2B. I'll put it into the 2B availability zone, and I'll call this 10.0.2.0/24. Alright. Okay. I have created only 2 subnets. I'm not creating the third subnet in the third availability zone. Why? Is because we are going to be setting up a DMZ architecture, and within this DMZ architecture, what is going to be happening is, the instances within the 1.0 subnet will be able to communicate to the outside world. The instances within the 2.0 will not be able to communicate to the outside world. Rather than that, they will allow communications only from within the instances from 10.0.1.0 network. Alright. So this is the setup that we are going to be doing. Okay, so we have 2 subnets created. Let's come back to the route tables in a bit. Okay, and let me come to the internet gateway. So let me create an internet gateway now. I'll call this as custom IGW. Okay, and let me create this. Now, once I'm creating this, the internet gateway was created, but it is not attached to any VPC. So I can go and attach to the VPC, and you select the custom VPC here. Okay. Alright. Sounds fair enough now. So VPC was set up, subnet was set up, route table is set up, internet gateway. The route table is yet to be set up. The internet gateway is set up now. Okay. Now, let's come back to the route table. Okay, so within the route table, we have one route table which was created, and it is the main. Okay, let me go to this route table ID, and what I'm going to do here is I am going to assign only one subnet here. Okay, so I'm going to use the 2A. Okay, I'll select the 2A subnet, and I will put it within the main route table. So which means whatever communication is going to go to the outside world will route through this, will look for this route table ID. So I need to create one more route table. Okay, so I'll create another route table now. Custom VPC RT, and this is the private route for the private route table. So I'll keep it as PRIV custom VPC, and I'll create the route table. Let me come back to the route tables here. So let me go ahead and edit this one. I'll call this as custom RT1 and pub. Okay, which means that this route table is for public connectivity, and this one is for private connectivity. Okay, I'll keep the names same. Okay, custom VPC-RT-pub. Okay, so now if you see here, what has happened is the primary one which got created along with the VPC is showing as main, and the one with private is showing as not the main. Okay. So this one we have the first public one, we had already associated one subnet. Let's go to the private one and associate the second subnet now. That was 2B. Okay, I'll set up this one. Okay, so that looks good. Now what we need to do is we know what a route table is, right? So a route table is like a dashboard at an airport, which is going to tell you what is the which airline, what is the flight number, so from where it is going to originate, where is the destination. All this information is going to be there in the dashboard. Likewise, the route table lets the instances within that network or the resources within that network be aware of the route it needs to take to transfer or transverse its data to the outside world. Okay, let's say if it's going to be outside world, then you need to we are going to teach the we're going to make the route table aware of that. And if it's going to be internal, we are going to be keeping it like that. Okay, so now we have the subnet, the route table, and the internet gateway. So the internet gateway is the one which is going to be carrying the data to the outside world and bring the data from the outside world into the instances or resources within the custom VPC, right? So what we need to do right now is within the route table, in the public route table, okay, we need to make it aware of the specific route. So let's go and edit route. There is one route automatically added there. So what I want to do is I want to allow the data to travel to the outside world and allow data from outside world to come in. So I'm selecting the 0000/0, and when I click on the target, it's going to give me a list of the targets. So I have egress only internet gateway, then instance, gateway load balancer endpoint, internet gateway, NAT gateway, network interface, peering connection, virtual private gateway. But for this specific task, let's go and select the internet gateway. So the moment you select the internet gateway, it will list the internet gateways which are available for us. So this is the internet gateway that we have to use. So we'll select this one and let's save the changes. Okay. So now what has happened is every instance which is associated or which is deployed within the public subnet will know how to send the data to the outside world and how to allow and when the data is coming inside, it has to travel through this IGW. So that is what we are making the instances aware, not just the instances, whatever resources within that particular subnet. Okay. All right. Now let's go and have a look at the private route table. So as for the private route table, it is aware that all the data, transfer is going to be happening within the VPC. So that is why the primary local VPC is going to be let there only. But we have already done the subnet association here. So we have completed the setup. Okay. So let's just review the setup here. We have created one custom VPC. We are using IPv4 CIDR 10.0.0.0/16. Okay. So then we created two subnets, which are custom subnet is 2A and 2B. Okay, so one is on 1.1 is using the 10.0.10/24 network range, and another one is using 10.0.20 network range. And here you can see the total number of available IPv4 addresses. Okay, quickly to make you understand why it is showing 251. Remember, 0 is not used. Okay, 1 is used for gateway. Okay, then 2 will not be used, or it is reserved by AWS. Okay, then 255 also cannot be used due to the broadcast nature of it. Okay, so when you're going to be question, this is a very common repetitive question that occurs in the solutions architect, developer associate, DevOps professional, all the exams, this question keeps repeating again and again and again. So the total number of addresses that are usable within a single network range, is always going to be 251 only. Please remember this. It's very easy, and you can easily score here. Okay. Next, what we have to do is we have to go and set up the environment in such a way that the machine in the public IP address or the machine in the public subnet only will be able to access the machine within the private subnet. And how we are going to use the PEM file and all that, let's see now. Okay. Now let's come to the instances. So we do not have any instances running. So this whole setup was set up. The whole setup, I've done it in Ohio. Alright, so just want to make sure that I'm doing it in Ohio for the instances also. So first I'm going to be launching instances, and I'll take the Linux 2 AMI, and as usual it's going to be the T2 micro. And here you have to watch it carefully. The network you have to change, okay, the custom VPC, and I am going to put it in the, by default it is automatically taking 2B, and when it is in 2B you can see that the auto assigned public IP is currently showing as disabled as per the subnet setting. Okay, but I'm going to put it in 2A now, and I'm going to make it enabled. So only with this option what will happen is you will have a public IP address automatically associated with that particular instance or resource. But for the sake of for the purpose of this particular demonstration, it's about the instance that we are going to be talking about. So I have already set the auto assign public IP to enable. Alright, so yeah, that's pretty much here. Next, add storage, add tags, configure security group. So remember, within this custom VPC, we have only one default VPC which has been created. So let's go ahead and create one custom security group, and I'll call this as SSH security group, and I'll leave the description as it is. I'm not going to change this. So here it's going to allow SSH connections from anywhere in the world. Okay, and I'll go review and launch. Let me launch this. But remember here the important part is the instances within your private subnet are going to be accessing from within your public subnet instances. So we need to have the key pair created here. So I'll create a new key pair, or let me check if I have a key pair already. So no key pairs found. Okay, I'll create a new key pair, and I'll call this AWS KP Ohio. Okay, and let me download the key pair. Okay, it's now downloaded. The PEM file is now downloaded. Let me go ahead and launch the instance. Okay, instance is now launching. Very nice. Now let's come back to the view instances, and you see that there is a public IPv4 address which has been assigned to this particular instance. Why? This instance is created within the public subnet. This instance can communicate to the outside world. Alright, now let me create the next instance. And this instance is going to be created within the private subnet, will not have communication to the outside world, meaning it cannot, inward communication is not going to be allowed from the outside world also. The inward communication is going to be only from within the instances which are within the public subnet. So that's the way we have to set it up, right? I'll use the T2 micro, configure instance details, and I'll change the default VPC to custom VPC, and I'll put it in the US East 2B, and subnet setting is disabled, which means that it is not going to get a public IP address. Next, add storage, add tags, configure security group. So now here it is a very important part. So I'm going to allow SSH TCP custom, and it is showing at the moment from all around the world or from anywhere in the world. Let's go and change this. So let me go to the services. I'll go to EC2. There are two methods of getting this set up. setup 1 is, let's say I can go to the instance ID, I can pick up the private IP address of the instance, and I can use the private IP address and say, okay, only from this address you have to allow. Alright, or I can say any instance from within this range can be allowed. So what I'm going to do is I'm going to use the specific range. Okay, so I want to have a wider access. Okay, 1.0/24. So any request coming in from 10.0.10.24 any instances from within 10.0.10/24 only will be allowed. Okay, so are we clear about this? Okay, so that's good. So review and launch. All right, now launch, and I need the key pair again. So I'm going to use the key pair which I just created, and I'm going to launch the instance. Good. So now the setup has been completed. Okay, now the next step is, let's go ahead and convert the PEM file to the PPK file, because we need the putty to access it. So, sorry, that was putty gen. I had to open, and I'm going to load, and I just downloaded the PEM file. Yeah, that's the file I just downloaded. Let me open it. Successfully imported. Key comment, let me remove it. Passphrase, I'll keep it as test 1, 2, 3, 4. The passphrase can be anything of your choice. Save private key. I'll put it into the documents, and I'll call this as kp-ohio-priv.ppk, and let me save this. Okay, so the setup is complete. All right, now the next step is to connect to the instance. So let me go to putty. I'll open the putty, and let me copy the public IP address. So this will be EC2-user at the IP address. I'll just change the font settings for better visibility, color to make it more clearer for us. I'll select a bright color, then I'll go to the SSH, auth, allow agent forwarding, browse, and I'll select the Ohio Priv, and I'll open it. So accept, and it's asking for the passphrase now, and let me enter it. Well, I am now into the instance which is sitting within the public subnet. Now the machine within the private subnet can be accessed only from instances within the 10.0.10 network, right? So let's go and set that up. So the second machine is already up, and it's got 10.0.2.74. Let's do a little more tweaking here. Let's go to the security group, and we have a security group which got created for the second instance, right? So this is the primary instance, and let me check out the second one, and it is associated with the security group Launch Wizard 1. Okay, so that is Launch Wizard 1. So this is the one that got created or associated with the instance in the private subnet. Let me edit inbound rule, and I'll add the ICMP. So what is this ICMP? ICMP is used for allowing pings, and this too I want to allow only from the 10.0.1.0 network. All right, and let me save it. All right, it's getting set up now, so that's done. So let me go, and so this is the private IP address of the second instance or the secure instance. Okay, let me ping 10.0.2. 74. And when the access has been set correctly, and now I'm able to ping the second instance or the private instance, which is now accessible only from the public instance. Alright, okay, good. Now let's see how to go and access this secondary instance or the secure instance from the public instance. Remember, this public instance, which is going to be the entry point for all your private instances, is going to be called as the Bastion server, or it's called the Bastion station. Okay, Bastion server or Jump server. Okay, so these are the names that we call for this server. Why? Because the server is used for accessing your secure infrastructure. Alright, but now the next step that I need is to upload the PEM file, which I had already created. So how do I do that? Let me go ahead and use WinSCP. Okay, let me open WinSCP and I'm going to use SCP here. So the host name is ec2-user at, and the IP address of the machine is, I'll copy this. Okay, username is ec2user, password is test1234. I have to go to advanced again. I have to go to the SSH and authentication, allow agent forwarding. I have to select the private key file, which is the Ohio file. Okay, I'm gonna log in. Yes, it is now logging in, and it will ask me for the passphrase again, and it's asked me, and I'm going to log in now. So now I can access the remote directory. So what do I need now? I need the PEM file to be copied to this machine, right? Okay, I'll go and copy the PEM file. Okay, so now the PEM file has been successfully copied. So let me come back to the primary instance or the public instance here. Okay, so now what I want to do is ls, let me check that. Okay, so right now the permissions on this particular PEM file are 644. Remember, we have to change it to 600, and good. Yes, so now the next step is we want to SSH from the public instance to the private instance, or from the Bastion server. When I mean the Bastion server, it is the public server. So how do I do that? SSH-I followed by the name of the PEM file, followed by the host name, which is followed by the username, which is the ec2-user at, and the instance password, the instance private IP address is 10.0.274. Okay, 10.0.2.74. all right, let me hit enter. Yes, I'm now logged into the second machine or the secure instance. So this is how we are going to be setting up a DMZ. This setup, we call it as a DMZ setup, all right, or more as a secure setup, or a Bastion server, or a Jump server setup. So there are many names to this setup, but the whole point is, there are two parts to it. One is we have set up a custom VPC. We know what are all the components associated with the custom VPC. And the second part is we know how to set up the Bastion server and how to access a private server from within a public server. So the setup is complete. Thank you very much for watching this session, and I will see you in the next session.